So student, in the last lecture we had learned how to draw three-dimensional structure on paper or a blackboard. So there are uh, 3 to 4 different ways by which you can draw the structure on a board or paper. That is your Newman projection formula, Sawhorse projection formula, and your Fisher's projection formula. Okay, so in a Newman projection formula, dot represent, or the point represent the front carbon, and the line emerging from that point represent the substituent that is attached to first carbon, and the circle represent the second carbon, and the bond emerging from that circle represent the substituent that is attached to that second carbon, or a back carbon. Okay, and again in the last lecture we had learned the Sawhorse projection formula. Okay, so for example, in case of ethane, the two carbon atom are drawn as a point, two carbon drawn as a point, and the bond joining that two carbon is drawn by line, and which is considered to be on a plane of paper. So, and it looks like a horse, that's what is called as Sawhorse projection formula. So again in the last lecture we had learned Fisher projection formula. So it is drawn by intersecting horizontal and your vertical line. So the group which present on horizontal line, that groups are towards the observer, and the group which present on vertical line, they are away from the observer. And one more method to represent three-dimensional structure, that is the solid and dashed line formula that we had already learned. So I will show you solid and dashed line formula, how to draw that solid and dashed line formula. Okay, so solid and dashed line formula of ethane, solid and dashed line formula of ethane. Middle carbon, and solid dash line, this is your solid line, dash line, this is your solid line. So hydrogen is there. So this is the solid and dash line formula of ethane, solid and dash line formula of ethane. Okay, now in this structure, the towards the observer, yes, present on dash line, that is away from the observer. So this is your line formula of ethane. So this is your carbon number first, carbon number second. This carbon is attached to 3 hydrogen. So this hydrogen which is present on this simple line, it is in a plane of paper. This hydrogen away from the observer, which is present on dash line, and the hydrogen present on this solid line, this hydrogen, the group which present on solid line, it means that whatever the group is there, that is towards the observer. Same for the second carbon, the group present, the hydrogen present on this simple line, it is in a plane of paper. Yes, a solid wedge and dash line formula. ठीक है, so it's a wedge and dash line formula. So the group present on this dash line, it means that this group is away from the observer, and the group which present on solid line, it means that that group is towards the observer. ठीक है, now we'll interconvert this We'll interconvert this solid to Newman, Newman to Sawhorse, and Sawhorse to Fisher. Sawhorse to Fisher. Sawhorse to Fisher. Simple line. This hydrogen, 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 and front carbon. This is the structure of ethane, CH3, and this is in a eclipse form. Here's a hydrogen, 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 hydrogen. This whatever the group present on first, they are maximum of the dihedral angle, and the dihedral easily you'll get this formula of molecule, Fischer projection formula of hydrogen with hydroxy group, tartaric acid, Newman projection for group, and this below 2 hydrogen by carboxylic, same this 2 hydrogen by hydroxy group, and this below hydrogen by COH group, and you can easily convert horse into Fischer projection formula. So this is the interconversion of tartaric acid into different projection formula, that is solid and dashed line, Newman projection formula, then your Sawhorse projection formula, and Fischer projection formula. So this is all about different conformation and their conversion. The next point that I'm going to teach you, that is conformational analysis of alkane. Conformational analysis of alkane. Conformational analysis of alkane. Conformational analysis of alkane. So first let's see what is conformation and what is conformational analysis. So you know what is the conformation. So the various three-dimensional arrangement that arises due to rotation around the carbon-carbon single bond in alkane molecule is called as conformation. You know that in alkane that this single bond is rotatable, you can easily rotate that, and different three-dimensional arrangement that arise due to rotation of this carbon-carbon single bond, in alkane is called as conformation, and the study of energy changes occurring during such rotation is called as conformational analysis. The study of energy changes occurring during such rotation. The study of energy changes occur during such rotation is called as conformational analysis. So let's see the conformational analysis of ethane. So this is the structure of ethane. Okay, having this CH3 CH2. Hello, yes. Okay, so we'll see the conformational analysis of alkane. So what is meant by conformation and its conformational analysis? So we have already learned what is conformation in your isomer. ठीक है, so you know that uh, uh, this stereoisomer have been classified into two types, that is conformer and rotamer, and that is configurational and conformational isomer. So this conformation means the various three-dimensional arrangement that arise due to rotation of this carbon-carbon single bond, in alkane is called as conformation. Your ethane is a alkane. Okay, so this carbon carbon single bond, you can easily rotate that, and different three-dimensional arrangement that arise due to rotation of this carbon carbon single bond is called as conformation. And the study of energy changes occurs during such rotation, is called as conformational analysis. So now we'll see the conformational analysis of ethane. So this is the structure of ethane, CH3CH2. So the convenient way of representing the conformation is by Newman projection formula. So we'll write the Newman projection formula of ethane. So this is in a eclipse form, this is in a staggered form. Okay, so this is your front carbon, 6 hydrogen form, and this is in a projection formula of eclipse and staggered form. 60 so at dihedral angle 0, so at 60 degree you will get staggered conformation. Again, when you rotate to 60 degree, it means that when you rotate to 60 degree, okay, so at 120 degree again you will get, when you rotate this first carbon to 60 degree, suppose this is your label carbon, a label hydrogen, when you rotate this label hydrogen, okay, to 60 degree, you will get this staggered conformation. Again, when you rotate this staggered conformation, this first carbon to 60 degree, you will get at 120 degree, you will get again eclipse conformation. Again, when you rotate this your eclipse conformation to 60 degree, so at 180 degree you will get staggered conformation. Again, when you rotate to 60 degree, so at 240 you will get eclipse conformation. And again, when you rotate 60 degree, so at 300 degree you will get staggered conformation. Again, when you rotate to 360 degree you will get your what, eclipse conformation. So these are the different orientation when you rotate this. Okay, what, so this is your eclipse conformation, and this theta represent the angle between the hydrogen present on first carbon and the hydrogen present on second carbon. This angle is 0 degree. When you rotate this to 60 degree you will get staggered conformation. Okay, so at you have to rotate this first carbon at 60 degree interval. Okay, so at dihedral angle 0, 120, 240 and 360. At dihedral angle theta 0, 120, 240 and 360, you will get this eclipse conformation. And at dihedral angle 60, 180 and 300, you will get this staggered conformation. So this staggered conformation, high energy conformation, it is a high energy conformation, while this staggered conformation, it is a less energy conformation. High energy means less stable, less energy means more stable. And the energy difference between these two conformation, that is eclipse and staggered, is it is 3 kilocalorie per mole. It is 3 kilocalorie per mole. It is 3 kilocalorie per mole. Okay. Now let's see its energy profile diagram. So before, did you understand what is conformation and conformational analysis of this ethane? Okay. So at dihedral angle 0, dihedral angle means the angle between the substituent present on first carbon and the substituent present on second carbon. So in ethane, the substituents are hydrogen. So this present the angle between first hydrogen and second hydrogen. The angle is 0. So at this dihedral angle 0, you will get this eclipse conformation. When you rotate to 60-degree, the dihedral angle is 60-degree, and you will get this staggered conformation. Again, when you rotate to 60, it will become 180. So at 180, again you will get eclipse conformation. And when you rotate to 60, so at 180-degree, you will get staggered conformation. Again, when you rotate to 60-degree, so it will become 240, and at 240-degree, you will get eclipse conformation. Again, when you rotate to 60-degree at 300-degree, you will get your staggered conformation. So at dihedral angle 0, 120, 240 and 360, you will get eclipse conformation. And at dihedral angle 60, 180 and 300, you will get staggered conformation. So this is your and E for eclipse conformation. So this staggered conformation is this second one, is more stable, and it is a less energy conformation, because there is no steric hindrance between the hydrogen present on first carbon and the hydrogen present on second carbon. So at the dihedral angle 60, 180 and 300, this dihedral angle is 60-degree. The distance between the substituent, the hydrogen present on first carbon and the hydrogen present on second carbon, is 60-degree. So that's why there is no steric hindrance. That's why this staggered conformation is a more stable conformation. While at this dihedral angle 120, 240 and 360, this angle between the hydrogen present on first carbon and the hydrogen present on second carbon is 0. Okay. So that's why the steric hindrance takes place. There is a steric hindrance between the hydrogen present on first carbon and the hydrogen present on second carbon, and hydrogen present on second carbon. Okay. So that's why it's a high energy conformation, because due to this steric hindrance, the energy of this conformation increases, and the energy difference between these two conformation is 3 kilocalorie per mole. Okay, now let me show you that. Can you see this? Hello? Okay. Okay. So this is the energy profile diagram. Energy profile diagram. It is plot of potential energy on this axis. Potential energy, PE means potential energy, and versus this dihedral angle. Okay, so from this top to bottom, energy of the molecule increases. E means this, E means eclipse conformation. E means eclipse conformation, and this S means staggered conformation. S means staggered conformation. So at dihedral angle 0, you will get eclipse conformation. ठीक है, and when you rotate that first carbon to 60 degree, you will get staggered conformation. Staggered conformation is a less energy conformation. Okay, and the energy difference between these two conformation, eclipse and staggered, is 3 kilocalorie per mole. 3 kilocalorie per mole. Again, when you rotate, you will get eclipse conformation at 120. Again, when you rotate to 60, at 180, you will get this your staggered conformation. Again, when you rotate to 240, you will get eclipse conformation. So this is energy profile diagram. This is your energy profile diagram of ethane. Energy profile diagram of ethane molecule. Energy profile diagram of ethane molecule. And this is the energy difference between your eclipse and staggered conformation, that is 3 kilocalorie per mole. 3 kilocalorie per mole. ठीक है, so this is about your conformation and conformational analysis of ethane. Now we will see the conformational analysis of propane. So for propane, just you have to replace one by CH3 hydrogen. CH3, now it is correct. So when you rotate this first carbon to 60 degree, you will get this staggered conformation of propane. ठीक है, so at dihedral angle 60, 180 and 300, you will get staggered conformation, and at dihedral angle 0, 120, 240 and 360, you will get eclipse conformation. Okay, so again, when you rotate, this CH3 will come here. So in this way, rotation, you are going to rotate this first carbon, and in this rotation at the interval of 60 degree at dihedral angle 60, 180 and 300, you will get most stable conformation, that is your staggered conformation. And at dihedral angle 0, 120, 240 and 360, you will get this eclipse conformation, and this eclipse conformation is a less stable conformation. And one more reason is it's a high energy conformation, because there is a steric hindrance takes place between this methyl group and hydrogen, in eclipse conformation. That's why due to that steric hindrance, the energy of the molecule increases. That's why the molecule which having high energy, that is less stable, and while the molecule that having less energy, so that is the most stable. So this staggered conformation is a having less energy, that's why it's a most stable. So this is the conformation and conformational analysis of your conformation and conformational analysis of propane molecule. So the energy barrier, that is eclipse to stagger, the energy difference, eclipse and stagger, this energy difference is 3.3 kilocalorie. For ethane, it's a 3 kilocalorie per mole, and while for this propane, this energy difference, energy or the energy barrier is 3.3 kilocalorie per mole. That is this 0.3 kilocalorie per mole higher than the ethane. It having 0.3 kilocalorie higher than ethane, and this difference, this 0.3 difference is due to the steric strain or steric hindrance between methyl group and hydrogen atom. Methyl group and hydrogen atom, because this methyl group is bulky group. So due to this methyl group and the due to this methyl bulky group, there is the increase in energy, that is 3.3 to 3.3 kilocalorie. Okay, so this 0.3 kilocalorie per mole of higher energy than ethane, and this difference is due to steric hindrance between methyl group and hydrogen atom. So this your propane having two conformation, basically two conformation, that is eclipse conformation and staggered conformation. Eclipse conformation and staggered conformation. So we get eclipse conformation when the dihedral angle is 0, 120, 240 and 360. In this conformation, the hydrogen and CH3H methyl H eclipsing interaction are observed. In this eclipse conformation, what the hydrogen and CH3H eclipsing interaction are observed. So this hydrogen and CH3H interaction are observed. That's why there is an increase in energy than ethane. Okay, the propane having higher energy difference, that is 3.3 kilocalorie per mole. Okay, and this is due to CH3H and HH interaction. CH3H and HH interaction, because in ethane there is only HH interaction. There is HH interaction. That's why the energy is 3.3 kilocalorie per mole. While in propane, it having two different types of interaction are there. That is hydrogen and CH3H methyl H interactions are there. It is two interaction are observed. So this is about an eclipse conformation. Then second is your staggered conformation. When this C2 is rotated through 60 degree, the group are attached to C1 and C2 become maximum away from each other, and it is also obtained at dihedral angle 60, 180 and 300. 60, 180 and 300. 60, 180 and 300. Staggered conformation is more stable than eclipse conformation. Staggered conformation is more stable than eclipse conformation. Now let's see its energy profile diagram. Energy profile diagram. So this is the energy profile diagram of your propane. Okay, potential energy versus dihedral angle. So at dihedral angle 0, 120, 240 and 360, you will get eclipse conformation, and this energy difference, staggered to eclipse, this energy difference is 3.3 kilocalorie per mole of energy. And you will get staggered conformation at 60, 180 and 300. 60, 180 and 300. Okay, E means eclipse conformation, S means staggered conformation. This is all about the energy profile diagram, all about energy profile diagram of propane. ठीक है, any question? समझ लगा? Okay, very good. Now only one lecture is remaining. After one lecture we'll complete the syllabus. ठीक है? So when you are free, tell me. Yes, after 6 o'clock, 6 to After 6 o'clock? And what about in the morning? In the morning, are you free? 8 a.m. 8 to 9. मग आपण 8 ते 9 घेऊया ना. नाही ते बाकीच्यांचा प्रॉब्लेम आहे ना. मग काय आता संडे को ठीक. थांबा एक मिनिट, मी बघतो पुढचे आपल्याला म्हणजे बुधवारी लेक्चर मिळतंय की नाही, कारण की तुमची एक्झाम पण आहे ना. ठीक आहे, बघतो थर्सडे ना. ठीक आहे, एक आपल्याला एक मिळतोय, एक दिवस मिळतोय. एक्झाम कधीपासून तुमची? टायमिंग काय एक्झामचा? 20. हां म्हणजे म्हणजे पुढचा आठवडा पण आपल्याला मिळत नाही लेक्चर घ्यायला, बरोबर? ठीक आहे, मग तुम्ही संध्याकाळी फ्री आहात ना 6 ते 7? एकच लेक्चरचं आहे रे, एका लेक्चरला काय तेवढं आपला. त्यांचं सिलेबस काय त्यांचं बाकी आहे का? हां मग कधी त्यांचं लेक्चर? कधी त्यांचं कधी? उद्या का? उद्या ना मग. उद्याचा टायमिंग काय आहे उद्याचा? 1:35 ना. ठीक आहे, मग उद्या कन्फर्म, उद्या आपलं लेक्चर आहे. हां ठीक आहे, प्रिया मॅमचं लेक्चर मी घेईल आणि आपण सिलेबस कंप्लीट करूया. ठीक आहे. हां बोला. हां हॅलो. हो आहे ना. हो आहे. नोट्स ते मी अपलोड केली याच्यावर क्लासरूमवरती. ठीक आहे, मग ग्रुपवर टाकतो मी. ठीक आहे. मग मी आता कॉलेजला जाणार आहे, मग तिथून आल्यावरती वगैरे तर मला टाईम मिळाला की लगेच तुम्हाला मी शेअर करतो. ठीक आहे. ठीक आहे. ओके. नाव यू कॅन लिव्ह. ओके बाय. ओके बाय.